Hi everyone. In this video, I'm going to show you how to find the exact value of certain angles that are not on the unit circle, right? So unit circle, 16 trigonometric points where the x and the y values give you the exact value of sine and cosine, right? So, I'm just going to simply say there's a difference between rounding and an exact value. So if for whatever problem you were doing, you needed the exact value of a certain sine or cosine of a certain angle, this is how you would find it. So I'll start with sum. I'll first show you what the formula looks like. So here, I'll start sum. So this is the first identity. The sine of an angle that can be expressed with two angles. So you're going to be breaking it up. Okay, so let's say sine of 60, 30 plus 30. No, it's not a good one. A and B is different. Sine of 150, 100, and 100 plus 50. Okay, so let me just keep going. Can be given to you sine of A cos of B plus, now we change angles, sine of B cos of A. So you'll probably have to memorize them for calculus. So when you get to that point, right, you just want to be aware of, so it's sine and cosine in each. Sine of A, which means in the next example, the next part of the equation, it changes sine of B. Okay, but I'm not really going to go into how to memorize right now. And then if you wanted to find the cosine of an exact value, this one is a little bit different. This one has cosine first, minus, so that's a little bit tricky, and then sine after. So these are the sum identities. So how would you use it? Okay, so I'll try to do easy. I'll start with easy. So let's say I asked you for the sine. Also, I'm going to be working with degrees. Okay, so the Math Help Services examples are all in degrees. So I figured it's easier to learn this in degrees first. Plus, you can always convert radians to degrees, work with it, and convert back. Okay, so it's not a big deal. So let's say I asked you for the exact value. Okay, so this is example one. Exact value of the sine of 75 degrees. So I'm starting with an easy one in the sense that it's pretty obvious how we're going to break up 75. You always want to break up the angle. Okay, we want to decompose it into a sum of angles that are on the unit circle. So just quickly, I'm going to list, this is very helpful. I'm going to list all the angles that are on the unit circle in degrees. 150, let's see if I can hopefully get all, oh no, I missed one. Okay, I'll put it here. 135 is also there, 150, 180. Okay, so this is helpful. So you should have either your unit circle in front of you, but I'll do it this way. So all the angles in degrees. So 210, 225, 240, now where are we? 270, 300, 315, 330, and 360. Okay, so we have the exact values of all of these angles on the unit circle. Now I want the exact value of 75. The sum identity says if you can decompose the angle into two angles that are on the unit circle, then you can use the identity above. So let me show you how that works. 75 can be decomposed into 30 and 45. This is an easy one because there are not too many options. You're going to see in other examples that you have many options. Okay, but I wanted to start with the simple one. So we have, what does this equal? This equals the sine of 30 times the cosine of 45 plus the sine of 45 times the cosine of 30. Okay, so basically it's sine, cosine in each term and the angle switch. This is when we go to the unit circle. Sine of 30 is a half. Cosine of 45 is the square root of 2 over 2. Sine of 45, square root of 2 over 2. Cosine of 30, square root of 3 over 2. So this topic, okay, you cannot be afraid of radicals. You're gonna have to rationalize sometimes. And let's see what happens here. Multiplying is easy. Numerator times numerator, square root of 2. Denominator times denominator is 4. Numerator, square root of 6. Denominator is 4. If the radical is not the same, there's not much you can do. So the exact value of the sine of, oops, sorry about that. Oops, no. Okay, something's happening here. Sorry about that. Let's see. Okay, so the exact value of the sine of 75 is the square root of 2 plus the square root of 6 over 4. So there's certain calculators that would have actually given you this. Okay, if you put your calculator back to the degrees and check the sine of 75, my calculator, for example, actually gives me this value. Now, two things. You can be in a course that doesn't allow calculators, that's one thing, or your calculator doesn't give you this exact value. So if you wanted to be sure, you would check in your calculator, I won't do it now, check what the sine of 75 gives you in degrees, figure out what this value is, they should be very close. Okay, so now I will do a cosine sum. So that was sine, so I'm going to do cosine. I'm actually going to, let's see, have these on my page. Okay, so you would have them in front of you. These are the angles that we're going to be referring to. Yes, there's a little bit of trial and error. Okay, but I mean, we're not working with that many, this is 180, okay, that many angles. So, what's my second example? So my second example is I want the exact value of 165. No, sorry, of what? The cosine of 165 degrees. Okay, so we're doing sum. So how can we make 165 with, remember where I got these from? These are all the possible 16 angles on the unit circle where we have the exact values. So 165, usually what I do is I start at the beginning, okay, and I say 30. 165 minus 30, that's 135. Good, we already have one. Okay, so we have 30 plus 135. 165 minus 45 is 120. So 45 plus 120. Is there anything else? 165 minus 90 would give you 55. No. And 165 minus, would give you 165 minus 90 would give you 75, which is not there. 165 minus 120. See, so we have the two options. Okay. So I'll just go with the first one because that's what I said, but both of these would give you the same answer. So the exact value of the cosine of 165 I will obtain by decomposing or breaking up into 30 plus 135. So the formula, okay, so maybe I'll write it with without the, well, no, you have it on the other page. You can always pause and go back. So it's cosine of each first minus sine of each second. Okay? So that's what we're doing here. So I'll continue here. So that's cosine minus sine. Good. Cosine of 30 is the square root of 3 over 2. Cosine of 135 is negative square root of 2 over 2. Minus sine of 30 is a half. Sine of 135 is the square root of 2 over 2. So I'm just glancing at my unit circle, right? So you can have it up in front of you. The best way to do this, really, let's say you were doing a test in a few months, you're in calculus class, you're doing a test, you would take a few minutes to draw your complete unit circle that you've memorized, and then you would be able to access the values fairly quickly. Okay, so then we just multiply negative square root of 6 over 4 minus the square root of 2 over 4. Nothing else we can do except common denominator. You're going to see the values are very repetitive, right? Because really we're only dealing with 0, 1, a half, square root of 2 over 2, square root of 3 over 2. So this is what we have. This is the exact value of the cosine of 165. Okay, so I'm going to keep going. Now I will do the difference. So the difference formulas, I'll put them here. Again, we have sine and cosine, very similar. So we have the sine of a minus b. So sine a cos b minus sine b cos a. And for cosine, it's the opposite. So we have the plus. Okay, so we have cos A cos B plus sine A sine B. Okay, so let's do an example for difference. Now, here I'm asking you to do the difference formula. You're going to see on Math Help Services, you won't be asked. You'll just be asked to find the sine of an angle. You can decide if you want to express it as a sum or as a difference. Okay, so I'll end with that. So let's do the sine, the exact value as a difference, right? So the exact value of the sine of, which one did I say I was going to do? I wanted to do one here. 255. 255. Okay, so 255 as a difference. We have, let me go back and look at our angles here. Okay, so sometimes what I do, you can start at 360. Okay, you can ask yourself, so 360 minus 30. No, 360 minus, well, there has to be a 5 involved. So you would go through a few options. And there's one that I already found, the sine of 300 minus 45. Okay, so another way to do it, sorry, I forgot, I was saying that before. 355 plus 30 is 285. So we're close. 255 plus 45. We're already at 300. So that's another way you can do it. You can take your angle and start adding from the row. Okay, there's the trial and error, there's that method. After a while, you'll get used to this. So what does this give us? So we fill it in. Okay, so sine of 300 cosine 45, sine 45 cosine 300. So sine of 300 is negative square root of 3 over 2. Cosine 45 is this one. Sine 45 repeats. Cosine of 300 is a half. Okay, so that's negative square root of 6 over 4. There we go. So they're very, very repetitive values. It's actually the same answer as, or looks like the same answer as before, and that's the exact value. So what I'm going to do now, I said I was going to do two, but they're very similar. I'm going to do one last example where I'm going to ask you to find the exact value of, let's see which one I can do, of 300 or 255. Okay, so I'll do sine of 255 degrees. So you can decide if you want to express it as a sum or as a difference. Okay, so I just wanted to show you 255 as a sum. Okay, so here, let me put my list back. Let me put my list back here so we can refer to it, right? You would have it on your circle. So I'll start at the beginning. 255 minus 30 is 225. So you can either do it as a sum. Okay, I won't go through all of them, but I just want to show you. You can either do it as a sum. That's one sum. Let's see what else. 255 minus 130 is 135. Sorry, 120. Okay, so we can also do it as 255 minus hold on a second. What was I saying here? I wanted, oh no, that's the other, I was doing sum. I'm sorry. I was doing sum. So another option for sum would be 120 plus 135. That's another option for sum. Okay, let's see as a difference. 360 minus 45, no. 330, right? So basically I start with the highest and one of the lowest. So 360 minus 30 is 330, too high. 360 minus 60, 300, too high, right? So it's a little bit of trial and error. 300, okay, and then you would eventually get to 300 minus 45. So I just want to show you maybe whichever one comes first to you. If you're being asked to use a certain identity, then you would use that one. But if I'm just asking you for the exact value, you can decide. So actually, since I already did a sine, let's make it a cosine. Let's make this one a cosine, just so that we'll have done one of each. This would have been cosine. Okay, it doesn't really matter. And I wanted to show you that you can use either one. I'm going to use it as a difference. Okay, so the cosine, and obviously you can check your answer, you can do it both ways, of 255 can be given to us by using these values here. So the cosine of 300 minus 45 is equal to the cosine of each plus the sine of each. Okay, and then it's just a matter of filling in the values. Cosine 300 is a half. Cosine 45, square root of 2 over 2. Sine of 300 is negative, square root of 3 over 2. And the sine of 45 is this one here. We don't have a double negative here. So let's just complete it, right? Again, it's very familiar math by now. Square root of 2 over 4 plus the negative of this. So it's the square root of 2 minus the square root of 6 over 4. Okay, so that's just the sum and difference identities using, we're decomposing an angle into a sum or a difference of these 16 trigonometric angles right here. Okay, so video 2, just to give you a little warning, video 2 will be a little bit more complicated, where we'll be using also the inverses. So now we're going to have to find secant, cosecant, cotan, and actually tan. We'll also do 10.